Hey guys, today we're gonna do an at-home science experiment with things that you probably just have laying around your house. It's gonna be really cool and it's really fun and super easy to do. If you don't have any of these materials at home, it's really inexpensive if you want to go out and get them to try it, but I think you will probably have them, so let's get started. The first thing that you need is a glass of milk. Then you also need a Q-tip. You need dish soap. It can be any kind, and you don't really need a lot of it. Next, you need food coloring. And finally, you need a paper plate. I have 2 of them just to be on the safe side so that the milk doesn't, make the bottom soggy and then run through. But this one also has a more, what's the word? This is more set down. It's lower, so it looks like it can hold liquid. You don't want a really flat paper plate. You can almost use a bowl as well, but paper plates work the best. Alright, so here's my paper plate. Step 1 is to pour the milk onto the plate. Here we go. Just enough to fill up the plate. Alright, step 1 accomplished. Step 2. For step 2, what you're going to do is put your food coloring all over the plate. I did mine in just kind of a random pattern. It doesn't really matter what it looks like. If you want to make it fancy, you can, but I used all 4 colors. Didn't film myself doing this because it was not that exciting. So here's the finished look. Alright, step 3. I put some dish soap on this Q-tip. You just need a drop of it, and I know it's kind of hard to see in this light. Then, once you have the dish soap on the Q-tip, I'll do it so that you can see. You're gonna put it in the milk and voila, magic. You can pick it up, you can put it somewhere else. It may not work as well because I took it off. Yep. So let's see if I do. Oh look, it's moving there. Da-da-da. But you can put another drop of dish soap on. Oh, I got some bubbles there. You can put another drop of dish soap on your other side of your Q-tip. You can put it in. I think because there's already a bunch of dish soap in there, probably. Oh, whoa, bubble. Crazy. So depending on where you put it in initially is where the color pattern will start. But it looks pretty cool afterwards. It's like a weird, milky, soapy work of art. So that's it. That's the experiment. But as beautiful as it is, how does it even happen? Why does the dish soap make the milk and the food coloring mix like that? Why does it cause it to expand? I'm gonna tell you. So first off, the food coloring is only for show. It's just for us. Even if it wasn't there, the milk and the dish soap would continue to act the same. It just helps us to be able to see the reaction. So the simple version is this. Milk contains fat. The soap particles bond to the fat in the milk. So the reaction that you see are the particles in the soap rushing around to try to bond with the particles of the fat in the milk. It also has to do with the surface tension. Surface tension is just what it sounds like. It's literally the tension on the surface of an object. So when the dish soap on the Q-tip is placed into the surface of the milk, it actually decreases the tension. The heightened tension on the surface of the dish soap causes all the molecules to be pulled, which we see that effect with the food coloring because it's pulling or pushing away from the dish soap on the Q-tip. And that's that. That's our at-home experiment for today. It's super simple, and I'd like to see you give it a try if you have the materials. So if you do have the materials, it literally took me less than 5 minutes to do it. It's super quick, but it's a pretty cool experiment, and for someone who likes art of all forms, I always enjoy seeing that experiment done because it's different every time. So if you can do the experiment, go post the video on the template here. It'll say, put your video here. I highly, highly recommend it. If you cannot, It's okay, but you will be receiving some extra credit for science if you can do this experiment. And we're gonna do a couple other at-home experiments that you may have the opportunity to do. Again, if you want to get these supplies, they're not expensive, but most of you probably have these laying around the house, so I want to see what yours look like. Also, you need to make sure to answer the questions about this video and this experiment. Even if you don't do the experiment, you have to answer these questions. I'm gonna say it again. Even if you don't do the experiment, you have to do the questions. Thanks, guys. I'm looking forward to seeing your results.